Hello, Chem 1. Welcome to the third video of the week. This was relatively short. It's just a couple of practice problems showing you how to do a little bit more, a little smaller nuances of this stoichiometry. The last video, focused a lot on mass to mass conversion, going from mass to mole to mole to mass. This was going to look at some of the other measurable quantities, most specifically looking at volume of a gas at STP. The homework's the same. It's all on the same homework. There's not an additional homework for this slide. I just left this here. Actually, the last couple problems on your homework are using other units besides mass to mass, even though it's labeled mass to mass. Okay, so this is the flow chart that we're used to dealing with. And again, if you have not already printed this off, please do so. It's very, very helpful to make sure you meander your way through these types of problems. So let's look at this example. Now, this is the first of two examples we're going to do today. It says, find the mass of glucose that is required to produce 1.82 liters of carbon dioxide gas at STP according to the following reaction. So we have this glucose molecules decomposing down to an ethanol molecule and carbon dioxide. This is the process of fermentation. So it's going to break down the ethanol, and one of the things you're going to get is a bubbling of carbon dioxide. So using explicit method, we're going to go through the same process we had before. We're going to first write down what's given. What's given to us is the 1.82 liters of carbon dioxide gas. We're going to look at what is asked for, and we're going to, in this case, you're going to ask for the mass of glucose. So we're asked for a mass, and we're given a volume. So if we go to our flow chart, our mole diagram, we can see that we're going to start, well, it gives you the volume. So you're going to start up here in the upper left-hand corner. And then the second part is it's asked for the mass of glucose. So we're going to end up over here at mass. So we need to create a path, a plan that goes from the volume, yellow blob on the left-hand side, on the given side, to the mass on the right-hand side. So we're going to go down here to go from volume to mole. And then we're going to go from mole to mole. So we're going to go mole of the given material, which is carbon dioxide, to mole of the glucose. And then we're going to use the molar mass of glucose to find the mass, and we've got ourselves a plan. So this, again, is going to take 3 steps. They're a little different than the last video, because in the last video you used only molar mass and the balanced chemical equation. Here we're going to be using that 22.4, the molar volume of a gas. So we have a plan. Volume of carbon dioxide to moles of carbon dioxide, to moles of glucose to mass of glucose. So we're going to go across, and again, there are going to be 3 steps. So our 3 steps, for recall, first step is step A. What do we need in order to go from volume of carbon dioxide to mole of carbon dioxide? Well, for that step, you're going to need to use the molar volume of a gas, that 22.4 liters per mole that we are kind of used to. For the second step, to go from moles of carbon dioxide to moles of glucose, we need to use the balanced chemical equation. Now, balanced chemical equation in this particular question was given to you. So we look for the ratio between the 2 molecules. Glucose has a 1 in front of it, and carbon dioxide has a 2, so it's a 1-to-2 ratio. And then finally, for the last step, step C, we have to go from moles of glucose to mass of glucose. And for that, we're going to be using the molar mass of glucose, which is approximately 180. So we have recalled our 3 steps. And again, I can't emphasize enough this explicit method process. And the importance of that is to go through and take all the things that should be going on in your head. What's given, what's asked for, how am I going to get there, what do I need to get there? And you're doing all this stuff all at once, but you're doing it in tiny pieces. So we've got our 3 steps of the plan, and we have a starting point. We have a starting step we're going to go on. So in order to lay out the solve, we first start with what's given to us, the 1.62. Why did I do that? And I solved it for 1.62, so I apologize. I'm sure my numbers could be off a little bit. I have no idea why I did that. So anyway, 1.62 liters. I made a mistake there. It should have been 1.82, but again, the answer you're going to get here is using 1.62. Divide by 22.4, divide by the 2 over 1, putting the conversion factor so the moles cancel, and then the 180 grams per mole, and voila, you get a 6.51 grams of glucose. Again, I must emphasize or must bring the attention, I made a mistake here on my solve. This should have been 1.82. I guess last night when I was putting this PowerPoint together, I made a mistake. So I apologize for that. And this answer at the end is using 1.62 as your starting point. So if you did this 100% correct, it's going to be off a little bit. I probably should change this video, but I'm not going to. Okay, so that's how you get that answer. Now, for the second example problem, it's a little different, okay? For the second example problem, it's a little bit different because one of the things I want you to see is it says what volume of gas. It doesn't say which gas, it just says total gas. When you do this last reaction, this is the decomposition of ethanol down to its elements. It's going to break into three elements: carbon, which is a solid, soot, charcoal, coal, graphite, whatever, it's a solid. And then hydrogen and oxygen are both going to be released together. It doesn't like there's one piece that shoots off hydrogen, another part shoots off another pile of oxygen. It's all together. So in this situation, I want to know when this breaks down, what's the total volume of gas, both gases, hydrogen and oxygen together, that is able to be collected at STP when you start with 4.17 grams of ethanol. Okay, so let's see what we got here. So given to us is the 4.17 grams of ethanol. What's asked for is the total volume of the gases at STP. Okay, not just hydrogen, not just oxygen, the total combined. So we're going to go ahead and need to come up with a plan. We're going to use our mole diagram again. Now we're given our grams. And then we're asked for this time, okay, there's grams, and with this time we're asked for volume, okay? So we need to go to volume. So just like before, we're going to go from molar mass, we're going to go from mass to mole, mole to mole, mole to volume, and we're going to do these in subsequent steps 1, 2, 3. That's our plan, mass to mole to volume, mass to mole to volume. Mass of ethanol, mole of ethanol, mole of gases, volume of gases. So, what are our recall steps? For step A, we need a molar mass of glucose. So we look that up, we do the calculation, we find out that it'd be 46.0684. For part B, we need our balanced chemical equation. Now this one's a little tricky because we've got a 2 for every 2 moles of the ethanol. We have 4 total moles of gases, 3 plus 1. So we have a 2 to 4 ratio. We have for every 2 moles of ethanol, 2 there, we have a total of 4 moles of gas. And again, that comes from the fact that there's 3 moles of hydrogen plus 1 mole of oxygen. That's where the 4 comes from. And then for step C, we already saw we need a molar volume of a gas at STP, and that's at 22.4. Now it's time to put it all together. We always start with the given, which is the 4.17 grams of ethanol. We're going to use step A. We're going to flip that step A to put the mass on the bottom to make the grams cancel. We're going to look at step B. Again, we need to flip step B because we want to make sure moles of glucose, this is not glucose, moles of ethanol is in the bottom and the moles of gas is on the top. And then finally, we're going to leave the last one by itself so that we have the moles of gas cancel on that one. We do our math and we get an answer of 4.06 liters of gas. So when we take our 4.17 grams of ethanol and allow it to decompose down into its elements, we're going to get a total of 4.06 liters of the hydrogen and the oxygen combined. Now, another way we could have solved this was to get 2 answers to figure out the number of moles of oxygen, the number of liters of oxygen produced, and the number of moles of hydrogen produced, and then add those together. That should still give you the 4.06 liters. Okay, so again, relatively short video, less than 10 minutes. Wanted to talk about how to incorporate some of the other units, considering you're going to be asked to do that as part of the homework for this week. So what's next? Next week, we're going to be incorporating the stoichiometry using the multiple compounds that we have in this situation, and we're going to go back and revisit the empirical formula and determine how to determine the empirical formula using what are called combustion analysis. That's what we're going to focus on next week. Hopefully everybody's staying safe and healthy and practicing your social distancing. You guys have a great time. Until next time, toodles.